Okay, this is exam 2 for physics 102. In this first problem it asks which of these equations correctly describes the circuit. We just want to start with the first one. It says 80 plus 80I3 plus 1I3. Alright, that one's wrong because the 80 should be negative because you're going with the current along this branch right here. Here we have minus 80I3. That's starting here and going in this direction. Minus 1I3. Minus 30, that's correct. Minus 20I2. And minus 40, which is also correct. So that one is correct. Let's just go by the other ones. I1 plus I2 is equal to I3. Here we have, let's take this junction. We have a current I2 coming into it, and I1 and I3 going out. So the junction rule should say I2 equals I1 plus I3. So that one's not right. And then we have a 45 I1. That's plus 45 I1. That is going in this direction. But then we come to plus 20I2, so that's not right. So the answer here is B. Number 2, it says, what is the magnitude of the current I1 in this circuit? Well, we want to know what is I1. We can do a simple loop rule, just taking this outer loop. Let's go in this direction. That'll give me minus 40 minus 20 I1 is equal to 0, and then I solve for I1 is equal to 40 over minus 20. That's equal to negative 2 amps, but I just want to know what is the magnitude, so the answer here is A. What is the equivalent resistance of this circuit? Well, we first find the equivalent resistance of this branch. That's 1 over 3 plus 1 over 3 plus 1 over 3, and that's equal to 1. And then we just add that. That's like having two resistors in series, 1 and 1. And we just add that. 1 plus 1 equals 2. So the answer here for number 3 is D. It says an RC circuit consists of a resistor of 1 mega ohm and a capacitor of 4 microfarads. Assuming the capacitor is completely charged to a battery of 2 volts, how long will the capacitor require to fully discharge when it is disconnected from the battery? We need to calculate the time constant. That's going to be 1 mega ohm times 4 microfarads. The mega and the micro cancel out. That just gives me 4 seconds. But we need 10 tau to fully discharge. So that's equal to 10 times 4, which is 40 seconds. That's option C. Which of these statements about a household circuit is true? Alright, the household circuit is a parallel circuit. That is true. All devices in a household circuit operate at the same current. That is not true. They operate at the same voltage. As you add more devices to a household circuit, the potential across each device decreases. That's not true, because the potential remains constant. The circuit breaker turns off if IN is greater than IOUT for any particular device. That is not true. This is for a GFCI, ground fault circuit interrupt, not for a circuit breaker. Circuit breaker measures the current coming in, the total current for the whole circuit, and if that exceeds a certain amount, then it cuts off. So it looks like we just have option D for number 5. In this circuit, how much brighter or dimmer is bulb A compared to bulb C? Alright, bulb A has 10 volts, bulb C has 5 volts. Since P is equal to V squared over R, A has twice the voltage of C, so it is 4 times as bright. That's option A, is number 6. What is the potential across the resistor circled in this figure? Alright, well this is the same as we had before, so you recall these simplify to 2 1 ohm resistors. That means that since they have the same resistance, they split the voltage equally. So you get 10 volts and 10 volts. Add those up gives you 20 volts. So this 1 ohm resistor has 10 volts of potential. And so these 3, since they're all in parallel, also have 10 volts. So the answer here is C. In this circuit, what happens to the equivalent resistance as you add resistors in parallel? Let's see, the equivalent resistance decreases. That is correct. It does not stay the same. It does not increase. It doesn't depend on the value of the added resistance. The equivalent resistance decreases. On a circuit breaker, you have a 1200 watt heater, a 120 watt bulb, and a 120 watt radio. When you add a 480 watt television, the circuit breaker turns off. Assume all the devices operate at 120 volts. Which of these is the maximum allowed current? Let's see. We want to figure out the current that each draws. This draws 10 amps, 1 amp, 1 amp. So you currently have 12 amps of current operating on the circuit. And then when you add a 480 watt television, that's 480 over 120, gives you 4 amps. When you add 4 amps. That takes you up to 16 amps, and that's when the circuit breaker kicks off. So, the most logical answer to this is 15, and that was the most commonly given answer of those of you that got it right. However, if you gave 12, then that I also gave you credit for that. So it's either A or E, and I gave you credit. I said in class that that your limit of your circuit breaker, that you can go up to that limit, and that is true within some tolerance. But so either one of these answers is correct, either 12 or 15. A wire carries a current and sits in a magnetic field as shown. What is the direction of the force on the wire? You let your fingers go in the direction of I, to the left. They fold into the magnetic field, which is out of the page, and so it goes up. The force acts up is number 10. That's A. What is the direction of the positively charged particle when it enters the magnetic field as shown? Well, same thing. Direction of V, fold towards B, that goes into the page, that is D. Figure of this path shows a charged particle. What is the charge of the particle? Well, you have V going to the right, you have F going up, and your magnetic field is out of the page. Let's just let's just forget the F and consider our B and our V. This is B. V is to the right, B is out of the page. That would give you a force that is down. Given this configuration of velocity and magnetic field, that tells me that my particle, since the force is actually up, must be negative. So number 12 is B. Charged particle enters a mass spectrometer. The magnetic field inside the device is 0.4 Tesla. So B is 0.4 Tesla. The velocity is 2 times 10 to the 6 meters per second. And the particle's path is 0.052 meters. So R is 0.052 meters. Now, I know that R is equal to mv over qb. I'm going to solve this for m over q. That is equal to rb over v. And that is equal to 0.052 times b, which is 0.4, divided by v, which is 2 times 10 to the 6. This is equal to 1.04 times 10 to the minus 8. And then if we go up here and calculate m over q for hydrogen, this is also equal to 1.04 times 10 to the minus 8. So since we have a match here and here, the particle must be hydrogen. That's B. Two parallel wires are 10 centimeters apart. One wire carries a current 5 amps to the left. The other wire carries a current of 2 amps to the right. What is the force acting on the wires if their length is 12 meters? All right, so we want to know the force on the wire. The force on two parallel wires from your equation sheet, F over L, is equal to mu naught I1 I2 over 2 pi d. Then I solve this for F, which is 4 pi times 10 to the minus times 4 pi times 10 to the minus 7 times I1 and I2. They're both 5, so 5 times L, which is 12 meters, divided by 2 pi, and they are a distance of 10 centimeters apart, so that's 0.1 meters. So the force, if I calculate this, is equal to 2.4 times 10 to the minus 4. Alright, so that's either B or D, so we need to figure out, are they repelling or attracting one another? Let's see, both of them are, one of the wires is carrying a current to the left, and the other wire carries a current to the right, so we have a wire going in that direction and a wire going in that direction. The magnetic field, for example, due to this bottom wire at the top wire, is into the page. So the magnetic field due to this wire is into the page up here. So this is our magnetic field, and then the force due to that wire the force due to that wire is up. Alright, so both wires feel a force that is repelling because the currents are in opposite directions. So that is option B. Alright, which pole of a magnet points towards the magnetic north pole? The magnetic north pole is at the geographic south pole. So it's the south pole of the magnet that points to the magnetic north pole. Or you can think that for magnets, opposite poles attract. So the southern pole of your magnet on your compass is going to be attracted to the northern magnetic pole of the Earth. The point A is equidistance between these two long parallel wires. What is the direction of the magnetic field at point A due to the two wires? Well, let's take this first wire first. The magnetic field at point A is out of the page. And then for this wire, the one on the right, the magnetic field at point A is also out of the page. So the answer is those two add up, those two vectors, to give you a net vector that is out of the page. That's number 16. A wire carries a current of 2 amps in a direction that makes an angle of 20 degrees the direction of the magnetic field of 3 Tesla. What is the magnetic force on a 10-meter length of the wire? Well, F is equal to ILB sine of theta. That is 2 amps. L is 10 meters. B is 3 Tesla times the sine of 20, and that gives you the answer for number 17 is 21 newtons. That's option C. Which of these forms of radiation in the electromagnetic spectrum have the highest energy? A radio has the lowest, and then microwaves come next, and then infrared, and then you have visible, and then ultraviolet. So it's D. A ray of light travels from water to air. The angle of incidence is 45 degrees. What is the refracted angle? You say N1 sine theta 1 is equal to N2 sine theta 2. N1 is 1.3 sine of 45 is equal to 1 sine of theta 2. You solve this for theta 2. It's the inverse sine of 1.3 sine of 45. And that gives you your answer for number 19 is 67 degrees. That's C. A ray of light travels from water to air. What is the appropriate angle of incidence where total internal reflection will occur? Total internal reflection occurs when this angle, theta 2, is 90 degrees. So we get N1, which is 1.3, sine of theta, which is what you want to know, is equal to 1 times the sine of 90. And so theta equals the inverse sine of 1 over 1.3. For number 20, that is 50 degrees. Which of these relationships correctly describes the indices of refraction depicted in this figure? Alright, so we have a ray that comes along here. In order to bend the way that it does, it has to travel faster in medium 2 than it does in medium 1. That means that the velocity in medium 2 is greater than the velocity in medium 1. That means that the index of refraction in medium 2 is less than the index of refraction in medium 1. And so the correct answer then is C. N1 is greater than N2. Which physical property of glass allows for the creation of light dispersing prisms? Let's see, all of these things are true, but only one of them allows for the creation of light dispersing prisms. Light travels slower in the glass than air. That's not what causes it. It is B. Alright, prisms are always triangular shaped, but that doesn't create the light dispersion. And the index of refraction, that's true, but that's not what causes them to disperse light. Which of these phenomena suggests that light acts as a particle? Interference is a wave, reflection is a particle, refraction is a wave, photoelectric effect is a particle. So it's 2 and 4, that's option C. The speed of light in a vacuum is 3 times 10 to the 8th meters per second. Glass has an index of refraction of n equal 1.5. What is the speed of light in glass? V is equal to C over N, 3 times 10 to the 8th. Over 1.5 is 2 times 10 to the 8th. That is option A. Alright, this figure shows a person looking at a star in a box filled with water. The actual position of the star is as shown. Where does the person see the image of the star? So if you have a light ray that comes out, it is refracted away from the normal and to the person's eye, such that if you trace that refracted ray back, the image of the star appears to the right of the actual star. So that's C, and this is version A of the test.